Really? Ok. Muy buenas tardes, bienvenidos a todos y muchas gracias por estar acá en el seminario de investigación del Major de Investigación Operativa y el Departamento de Ingeniería Industrial. Hoy día tenemos el placer de contar con la profesora Alice Smith de la Universidad de Auburn, quien está actualmente en una visita en la Universidad Católica de Valparaíso y también está como visitante de Lightforce, como la Chair Committee de Lightforce, que se celebrará en Chile el próximo año, en el mes de julio. Así que los invitamos a todos a ver su presentación en innovaciones en el uso de drones para la logística última milla mesa. Please, Alice, go ahead.
Yes, I think if we can, I will.
Go ahead.
I'm not afraid of COVID. I'm for vaccinated. In the US, we don't wear these anymore. And rustic bags here, we call them masks. Whatever, I'm respectful of that, so I'm out. So thank you for inviting me. It's always a pleasure to come here. And so I'm gonna use the Spanish slides, we already have them. And but obviously I speak English. I'm actually a student of Spanish. It's a fun fact about me. At my university, I'm undergraduate Spanish major, I just started taking classes to learn, and one thing led to another, and I became a major, and I'm almost done with my bachelor's degree in Spanish. Pero no puedo hablar bien. Puedo leer, puedo escribir, muy difícil, especialmente en Chile. Okay, so I'm going to give you a talk. This is me, of course. This is with my colleague Daniel Silva, and most of you I think mentioned last week. There were actually two of our students. Nalwin is originally from Thailand and did one part of this work, and then one Carlos is Chilean. He's actually a student at the Pelican of Venezuela, and I'm co-advising him with Ricardo Bentica, and also Daniel's doing a lot of the heavy lifting, but unofficially.
Space bar.
No, because I'm not on the.
Oh.
Hang on. It's on. Since the slides, yeah, okay.
Yeah.
Okay, so our application is using drones or autonomous flying vehicles for last mile logistics. And we're particularly interested in a rural medicine application, although what we're doing is appropriate to certainly other things besides medicine. And we chose that because where Auburn is located in Alabama, it's quite rural and there's a lot of people. But this is also true in many parts of many countries, including Chile, where there's not good infrastructure to get medicines and return out in the rural environment. The other thing that makes the rural environment attractive is most of the work, at least the academic work done in drone last mile delivery, is focused more on urban, like delivering parcels in an urban context. But if you think about flying drones, we're a lot further away from that being practical in an urban environment than we are in a rural environment, because there's not a lot of obstacles and a lot of people and wires and other traffic. So we really feel the rural environment's been kind of overlooked. And so I'm going to present two different works. One is the more traditional, looking at using a combination of trucks and drones for last mile delivery to work by Nalwin. And the unusual thing about that is we consider pickup along with delivery, which really hasn't been done much at all. The other one is a little more novel, and we think a little more practical. which is using drones for resupply and trucks. All of the final deliveries are made by a truck, another conventional vehicle, but their resupplies continuously.
I'll ask you to, what's your voice, because the people are.
Okay, not maybe stand closer. Is this where the mic
Yes.
is? Okay. So this is, I think I already said, a lot of this stuff. In the medicine, so if you think about drones, what we need are small packages. They can't be really big and have a lot of heavy weight, which, you know, medicine and associated supply fits that bill. And then, of course, we actually started this work before the pandemic, but it's became even more kind of interesting during the pandemic because everyone was much more aware of medical needs of every people. So, quick run through the literature. There's been a lot of literature on drones, very, very active topic of research and operations research right now, especially for logistics. Murray and Chu, Murray was my colleague actually at Auburn. That's how I started in drones. And he moved to the University of Buffalo and he wrote with his graduate student Chu this in 2015. He called his where he's using the truck and drone tandem, the flying sidekick problem. So we're going to use that basically as and then we're going to add pickups to it in one part of the work. And since then, there's been a lot of work, a lot of stuff coming out of US, but also Europe, especially Northern Europe, Netherlands, Germany, doing a lot in drone logistics. So it's a fun topic. And we have drones too, not just computer stuff. Our group has some drones. So this is the first one that we're going to take the flying sidekick problem, and then we're going to add the twist that we can do pickups. So the flying sidekick problem is where you've got a truck and a drone acting in tandem. So this is traditional truck. This is a TSP, obviously. Here you've got a drone that rides along with the truck, but can be launched and then retrieved at different locations. And so the truck and the drone can make deliveries simultaneously, which of course can improve the overall time needed for the delivery. But of course, the drone is flying empty half the time because it's delivering and it comes back empty. So what we're adding is pickups. So let's talk about pickups. So I don't know how many of you, of course, I got all men but a woman, but how many of you buy stuff on the internet, especially like clothes? Even the men. So I don't know about you guys, but I return a lot of that. And I think everyone does. So returns are a lot. And as you know, with the pandemic, people are buying more and more online. And I think that's going to stay the way. I mean, I can go to stores in the US, everything's open, everything's like before almost. But it's so convenient to have the selection and convenience of buying online. And but if you're going to buy something like clothes, it's hard to say, well, if it doesn't fit or something. And so returns are really important. And of course, returns are important for other things too. If something is defective with the wrong item. So it's a large proportion. And customers want it convenient. Right now, if I get clothes delivered, it comes to my house. But if I want to return them, I have to package it and drive it to some sort of center that can then mail it back. So this is what we wanted to do, is also add pickup. And so how would this function? So again, we've got both returns and deliveries, and we allow that a single customer can have both. It can have a delivery and a return at the same time. And by the way, I'm going through things pretty quickly because I have a lot of ground to cover. And so we're going to add the flying sidekick here. And kind of showing you the roots. So what this does, what you have to do that's different than the original flying sidekick is you've got to kind of sequence things because the drone has a capacity that's quite small capacity. So sometimes you must drop off before you can pick up. Okay, so certainly if the capacity is one, it has to drop off before it can pick up. And so you have to keep track of all that. So from a model perspective, it's got similarities to the classic marine shoe model, but it's also got these extra things that have to be taken care of. And what we're looking at is the overall time to completion for a set of deliveries and pickups. And so these are just some of the constraints. Obviously, we've got a pretty classical constraints. I'm not going to read them. Eliminate subterms and the drone has a capacity. So we are assuming that all of the deliveries are interchangeable in terms of from a drone perspective. So they're the same size, same weight, same shape, okay. Which, you know, that's not totally realistic, but for medical things, it's probably not that bad of an assumption. And maybe for some other things like clothes, it probably would be fairly changeable. So these are our decision variables. Obviously, what's going to be, well, where is the drone going to launch from? Well, let me step back. Which customer will be served by the truck and which by the drone? What is the routing of the truck? Where does the drone launch from the truck and where is it retrieved? And of course, it does that multiple times or can do that multiple times along the route. So these are the decision variables. If the drone is going to make more than one stop on a sortie, what's the order of the stop? And of course, again, looking at the capacity constraints. So these are some of the things we needed to take care of and make decisions. So we've got the capacity constraints, and you can see here, it's kind of condition number 2. And the pickup and delivery. So here we're going to pick up, deliver, pick up. And so with a capacity pick up, delivery, pick up, yeah, with a capacity of 2, then it's fine to do this type of sequence. So we developed a model, we developed an exact model, we also have a heuristic model. Yeah.
Are you considering more than one truck, or is it single truck? And if you have more than one truck and drones, are you interchangeable?
Okay, so
Are they
yes
interchangeable?
and no.
Mhm.
So what I'm showing you here, I think is one truck only,
Mhm.
but our current work, we're doing multiple trucks where a drone could be shared.
Alright.
Is that true? That is not true. I lied to you. That's one Carlos's work. This work is one truck, and I believe the current work that the student doing is multiple trucks, but we're not sharing the drone.
Right.
Because the drone gets launched and returned to the truck. I'm really not a dizzy person. Daniel Silva and I have like 6 students working on drone stuff, and sometimes I get it confused, like, okay, which model? And there are various, you know, you do one model, then you go to another, so like, okay, which model is this, and what are the assumptions? So anyway, so we this is for the exact model. So honestly, computationally, this thing is not friendly. It takes a long time, so we can only do small problems exactly. So these are for 10 customers, and what we're comparing with is the these are the percent returns. So if it's a single capacity with no returns, you know, essentially you've got the regular TSP, and this is the flying sidekick over here, which, okay, so it's the same. So this is And this is assuming, this is imperial units, 35 miles an hour with 40 minutes endurance, and that's the assumption for the drone. The truck goes slower than the drone because we're taking into account stops and traffic and whatnot. And the drone, of course, can fly Euclidean where the truck goes on the road network. So if we look at this in terms of the percentage in time of these things, when we compare it to a traditional TSP, which would be on a truck only, and the flying sidekick, we can get quite a bit of savings. Now, obviously, if the percent returns are 0, then we're the same as the flying sidekick. The flying sidekick considered only a capacity of 1. So here we're considering capacities of 1, 2, 3. And even with no returns, you're going to get improvements just because of the large capacity. But if we look at just capacity of 1, we're still getting pretty substantial improvements over the not considering returns, with returns of either 20 or 40%. Certainly 20% is a pretty conservative assumption. So you can see that even with capacity of 1, we're probably looking at 70%, kind of as a very, very conservative estimate. And as the capacity goes up, the improvements can go up too. We also developed a heuristic. I'm not going to go over it in a lot of detail. This is the flow chart, and it's a neighborhood search. It's an iterative neighborhood search. The gap optimality, I won't lie, we had to work really hard on the heuristic because there were a lot of problems where it didn't do so well, and we had to add some things. But we're getting about a little over 5% gap in average. And of course, it's a lot quicker than Cplex. We did some 15s, and we might have even done some 20s with Cplex, but we can't go bigger than that. And even then, if you think about, are we going to be able to run this thing for 4 hours to route, or maybe not? So we have to think pragmatically that even though it's physically possible in operational study, you don't have that much time to route these things. So these are some of the results from the heuristic. This is again on time on 10 customers, and we did this so we could compare how the heuristic does, and you can see it's quite good over in the last column. And of course the time is a tiny fraction, which is the whole point of the heuristic. So these are for bigger instances. So these are customers, obviously 10, I just showed you. We have 30, 50, and 100 that we're comparing. The TSP, which again is the truck only, kind of what is done now. And with the classical flying sidekick in the orange, and then our gray is our flying sidekick with pickup and delivery. So you can see overall, again, we're getting fairly decent savings. These are averaged over a number of instances. This assumes a return of 40% and a capacity of 3. So it's that bottom part of the table that I showed you. Okay, so some of the conclusions on this one. We think it has a good application in medical because people could be sending back like empties or even possibly some test results at home or something. So we feel like this is a good application. It does reduce the time pretty significantly, depending on, of course, the exact problem instance and aspects. The capacity of the drone is obviously really important. I mean, that's not going to be a surprise. And the heuristic is done well. We think it's not perfect, but it gives really good solutions, and it's very, very quick. Even for 100 customers is big. I don't think you could do 100 customers in a day, so it's probably as big a problem as we're going to have to do. So one of the things, so this work is actually, I believe this is the first work Daniel and I initiated with drones. The student is very slow to graduate, so he's been working a long time. And like I said, we started this quite a bit before the pandemic. But one of the things, as we were talking about our second student, who was Juan Carlos from Valparaiso, because Juan Carlos I have to say, he's a really good student, like really good. And I had him in class here, and that's why I knew. And then I told Daniel, I said, okay, I want this guy to do some work for me, because he's really, really good. I don't want to waste him, and I don't want to do just an incremental blind sidekick. And one of the things that always troubled me, as I said before, well, partly the flying thing, but also having drones interact with the customer. This is a big, big problem. You know, nobody in the academic literature is really talking about that. But if you think about it, you know, the drone has to land. What if the customer's not there? What if there's a dog that decides to eat the drone? Or a kid who wants to take the drone? And you say, well, you could have the drone drop it. Well, you know, that might damage the parcel, it might fall on somebody. So, and then once the drone's down, how does the customer, I mean, it can launch by itself, and then the customer has to, you know, get their materials out of the drone locker, put it back in, and then stand back. So there's a lot of potential for customer even harm, and certainly for drone damage. So, and if you think about it, you can't get rid of that, but you can get rid of it if you eliminate the customer dealing with the drone. So what we thought about was drone resupply. So we're still using the drone in last mile delivery, but instead we're taking it from the depot to the truck. And the truck actually makes all of the delivery. And to me, this is much, much more pragmatic in terms of being implementable. So we're going to roll into that. Before I do that, we have a virtual field trial of the model I just showed you. And hopefully the video will work. I'll have to do the video. For some reason, it won't let me change windows here.
Probably your mouse is on this window, so you'll have to drag it to the other window.
You want to come do that?
Okay, no problem.
I mean, I haven't done one where I'm doing the visual. Because I have to initiate the video.
Let's check our lead. So just to, we're on that window, but we need to, there you go. Which is the word?
The PowerPoint's down here.
And your video.
No, the video's embedded in the PowerPoint.
Oh, it's embedded. So let me put it here. So we just need to.
I just need to start it.
Yeah, exactly.
Este video muestra una prueba de campo virtual de una instancia del modelo del problema del agente viajero con drones para entregas y devoluciones. En este modelo, un dron y un camión son usados para la entrega y devolución de paquetes. En esta instancia hay 10 clientes. Aquí los vemos distribuidos en el entorno virtual. Las ubicaciones de los vehículos serán representadas por dos círculos. El círculo verde es el camión y el naranjo el dron.
You did alternate and the top view, and it shows you obviously over a here, and this is kind of at this point. The drone here is going to deliver, and it then goes rapidly and it's going to pick up. So here it's picking up, it's delivered, it's going to pick up. And now it's going to rendezvous. Correspond to this. Here the drone. The truck is actually the delivery there. I know. It's not about the drone. Again, you can see this is a role environment. That's a drone flying, podium, driving in the road network. I like how they show it in backwards. Where the rendezvous and doing more. What's happening in the rendezvous is the drive fleet to go and reload and the drones are all pre-programmed, so they can be with the account information and all of them. So the driver doesn't have to. And nobody has to do it in calculation for so we don't actually live in like cabins and we have a really big investment. On that.
Este video muestra una prueba de campo.
Okay, so now we're gonna do with the resupply, which I motivated a couple minutes ago. And I think I've said all of this stuff. So the version that I'm showing you here assumes that you know when the item's gonna be ready. So for example, think of like a pharmacy, so something's made to order. So the prescriptions have come in and you know, okay, this one will be ready by 10 a.m., this one will be ready by noon, this one will be ready by 2, and so on. Okay, so we're not dealing with stochastic orders at this point. We're going to, but not in this work. We're just beginning that work. So this is the deterministic version. What the idea is, you're going to route the truck. Okay, so basically a TSP kind of routing, but the truck, when do you send the truck from the depot? Okay, so you don't wait for all the orders, you send it, and then the drone, the other decision is when to send the drone to the truck to resupply with what orders. Okay, so these are, and this is the one you asked about, multiple drones. We have a version also with multiple trucks where the drone is shared. It's not on these slides. So this is the idea. I think I said all this. There's truck, and then we're going to. So when the drone, when the truck first starts out, we go back. Those are the orders ready. So there's 3 of them. As things become ready, we're now going to meet with the truck and bring 1 or more ready orders. So the decision variables are how to route the truck, when to send the drone, where do the truck and drone rendezvous, and obviously which orders to send with the drone. So there's a lot of things going on there. We assume, I think without loss of generality, that the truck and drone always rendezvous at a customer location, and we did the last one too. But you could add nodes to the network, so it's not restricted. But it makes sense too that that's what would happen. So this is some of the literature. Obviously, there's the drone part, but there's also kind of the release dates where, again, you've got orders becoming available during the day. And it's called release dates in our context, it's release times, because we're talking about planning for a single day of deliveries. And we only found a couple papers doing resupply by drones, and they're not that similar to what we're doing in a really understudied area. So this is what we talked about here: multiple trucks, multiple drones. There's a capacity, obviously. The trucks, and for all of our work here, the trucks are incapacitated. And the deterministic, which I just described. Yes.
Are you still considering pickups in this version of the
No,
Oh.
we're not.
Okay.
Because
Yeah,
we're,
makes sense.
I mean, there could be pickups, but that would be from the truck will carry the pickups.
Right.
There's no need to get the pickups back to the depot. I mean, we could, but no, we're not considering that. So this is an MLP, again, I'm not gonna go over all this stuff. But we have a model. Again, to solve this exactly is really hard. We use a decomposition approach, a math heuristic, where we're developing the TSP for the trucks, and then we develop the drones, and so it's not provably globally optimum, but I think in practice it pretty much is. And then we also, so we're using a taboo search to route the trucks, and then the drones route is actually exact. We can use an IP to route the drones once the truck route is made. That's all of that. So there's the truck route, and then we add the drone routes. And again, and you asked about multiple truck and multiple drones. So we do have versions of this where you have fleets of each. And again, everything's originated. We're assuming that all this works a single depot. And we did a lot of experiments. We're using Cplex here. Because he's a Chilean student, we're back in the metric system for this work. Trucks, drones, again, twice as much. Capacity of 45 minutes. This is kind of an interesting aspect. So we define this beta, and beta is when the orders become available during the day. So we're looking at a single day scheduling. So are the orders really spread out during the day, or do they all come towards the beginning? So we look at various distributions of that. And of course, if beta is 0, it simply means that they're all available at the beginning of the day. So this is 1 truck and 1 drone. Again, very small capacity of 4 of the drone. So in this case, the drone capacity really for resupply probably needs to be a little bit bigger, because you don't want to be sending the drone every time an order is ready. This is 10 customers. We looked at different values of beta. Beta's on the x-axis here. And these are instances from the literature that we modified. They have the depot in different locations, and they have the customers either all spread out or somewhat clustered. But you can see that we're always, and of course, as you'd expect, doing better than just the truck only. So if the truck had to either wait for it all or go back to the depot and pick up the orders, it's a longer overall time. This is for 15 clients. These are some box and whiskers plots. And again, look at the comparison here. We're looking at the comparison of drone capacity. So this is 4, which was assumed in the previous rule. This is 8. And you can see that actually going from 4 to 8, don't really get much. That's at least, and remember, this is only 15 customers. So in this case, 4 is a sufficient capacity. This is the effectiveness of the decomposition. Some CPU times. It's very, very fast. This is the truck part where we're using the taboo search. That's the one that takes more time. And the IP solving the drone routes are really quick. And you can see, the gaps are, obviously they've gotten bigger as we went up, and, we're trying to keep them low. Again, computationally, these have been problematic. To do it exactly takes way longer than you would have in practice. And you trying to look at a practical heuristic that works well and keeps the gaps fairly low. It's not easy. So these are some results with multiple drones, right? Yeah, 2 trucks and 2 drones. So the drones are not dedicated to trucks. They go to wherever they need to go. And again, here we're looking at different values of the beta, if it's closer together or more spread out. And this is looking at 1 drone with capacity of 4 versus 2 drones with a capacity of 2. And again, in this case, you actually usually get better with a capacity of 4 as opposed to the drones with 2. Yeah, he's got this. So this is for 10 and the optimization. Again, it's pretty effective. These are the ones I've already showed you down here. We were getting, we're definitely not meeting the exact solutions for these larger instances, but it's pretty good. Especially for 15, they're good. And then for considering limiting the MLRP model to an hour, which we thought was practical, of course, for the larger instances, we're getting much better results with our heuristic. So these are really big problems. So again, customers are 30, 40, and 50. This is kind of interesting. So this is the percent orders resupply, which means that the truck either leaves the depot or returns to the depot to get stuff in about 10 to 15% of the orders. The rest are all brought by drone. These are the number of drone sorties on average. So about 7, 8, 9, and then the number of orders resupplied for sortie. So I think it shows you that the drones are pretty heavily utilized in this context and makes quite a big impact. We have a paper in Computers in OR on the earlier part of this. It's not all these results. It's a single truck, single drone. We've got another paper. I'm not going to tell you where, but in revision. Right now, we're trying to get it submitted, I hope, this month, with the more complex versions. Do you want to do this again, since you have the magic touch of the video?
No problem.
So this again is a similar. I have to find it on the.
El problema de ruteo de vehículos con reabastecimiento de drones. Esta es una instancia del problema. Hay un depósito y 4 clientes, todos ubicados en la misma calle. El cuadrado representa al depósito y los círculos los clientes. Los tiempos de liberación de los pedidos están escritos arriba de cada nodo. Esta figura muestra una solución factible. Consideramos la velocidad del camión como una unidad de distancia por minuto y la velocidad del dron como el doble de la del camión. Además, consideramos una fecha límite de 90 minutos, lo que significa que el camión deberá regresar al depósito antes de este tiempo o incurrirá en costos de horas extra. El camión deja el depósito con las órdenes de los clientes 1 y 2. Mientras realiza las entregas, las órdenes 3 y 4 son liberadas. Un dron es enviado desde el depósito llevándolas. El dron llega al mismo tiempo que el camión. Una vez recibido los paquetes del dron, el camión continúa hacia el cliente 4 y luego regresa al depósito. En esta instancia, el costo de mano de obra extra pagado al repartidor corresponde a 10 minutos de tiempo extra. Si no utilizamos al dron, el camión debe esperar que todas las órdenes estén liberadas. Esto resultaría en un costo de 25 minutos de tiempo extra. Otra opción sería que el camión realice múltiples viajes, pero eso sería aún más costoso. En la esquina superior derecha podrán ver un mapa mostrando las ubicaciones del dron y del camión. El círculo rojo es el camión y el amarillo el dron. En la vista principal verán a uno de los vehículos y en la esquina inferior izquierda podrán ver al mismo tiempo qué está haciendo el otro.
Yeah, so the truck left with just 2 orders, and I was obviously making deliveries. Again, we're not considering pickups here, although it would be easy to add that. And he's gonna go to order 2, and then at that point, we're gonna get the drone launched any moment now. That's gonna be sent with more orders to resupply the truck.
There it goes.
Right. Now, the drone is not necessarily sent when the truck is empty of orders. I mean, it could be sent any time and during the truck's route. So the drone's leaving with 2 more orders. This is a very simple example. 3 and 4, and it's gonna rendezvous, I guess at wherever delivery 3 would be. So in this case, even though they're at customer 3, the driver would actually make the delivery, would receive the drone, unload 4 and 3 and 4, deliver 3, and then carry 4 in the truck to that client. So, and we do allow the truck and all this work actually we do allow wait time. So if the truck has to wait, that we allow that. We allow the drone to wait by hovering. So, and so it goes against the battery. And so here now the drone is resupplied, it's flying back empty to the depot. Number 3's been delivered, and the truck's gonna go ahead and deliver number 4. And then if you use this Unreal Engine, it's an open access
Looks good.
animation engine. Yeah, it's pretty cool. I gave this talk in Colombia in March, and some of them were familiar with the.
El problema.
Okay, so this is my last part. So when Daniel and I were writing the proposal for Toyota to do this work, you know, we had the virtual trials, we had the math models, we had the heuristics. But I was like, you know what, we need to do this in reality. So we put money into buy drones, and we did. And because I think you'll see, I mean, they're like baby steps, what we're doing, but it still adds a lot of, you know, looking at the pragmatic aspects, and the client, the sponsor was really interested in this, and they were very interested in the equipment side of it. So we bought this drone called the Terra drone. This is actually a picture of it. It's quite big. Again, it's programmed, so there's open source software that you use to program the route, and then it's downloaded to the drone. And so what we're doing here is now have a really, really, really basic actual trial. So I'm gonna try to do this.
Go ahead, and now click it.
Video veremos
Oh, okay, it wasn't that
Click it
hard.
again. You unclick it.
una demostración Del problema del agente viajero con drones para entregas y devoluciones. En este problema tenemos múltiples clientes que deben ser atendidos. Los clientes pueden recibir paquetes, devolverlos o ambos. Un repartidor dejará el depósito con todas las órdenes a repartir y además llevará consigo un dron para realizar algunas de las tareas. Algunos clientes son atendidos por el repartidor y otros por el dron. Este es el repartidor. Dejará el depósito con todas las órdenes de su ruta. El dron se encuentra dentro del vehículo. Aquí vemos al repartidor haciendo su primera entrega. A continuación, retirará el dron del vehículo. Ya que la siguiente operación es una entrega, cargará el dron y lo enviará hacia el cliente.
And now he's going to launch the drone. So this gives you a good idea of how, it's really, and we have this office and it actually.
El repartidor continuará hacia su siguiente destino. El dron llega a la casa del cliente.
That's me and my phone. So here's the drone.
Ella está esperando un paquete y también va a realizar una devolución. Primero recogerá su paquete y luego cargará el dron con el producto a devolver.
I'm doing a return. And you don't have to do anything.
El dron ahora regresará con el repartidor para entregar el paquete del cliente y realizar su próxima tarea.
Okay, and it should, I think, roll into the next one.
I think it stopped.
Okay,
Yeah.
maybe it's the next.
En este video veremos una demostración del problema del agente viajero.
Okay, all right, I didn't know if we put them in one or two.
En este video veremos una demostración del problema de ruteo de vehículos con reabastecimiento de drones. Un repartidor deberá llevar una orden a un cliente. Mientras el repartidor va en tránsito, una nueva orden estará disponible en el depósito. Dicha orden será enviada desde el depósito hasta el repartidor utilizando un dron. De esta manera, el repartidor podrá realizar la segunda entrega sin tener que regresar al depósito a recogerlo. Este es el repartidor. Lo vemos saliendo del depósito con la primera orden.
So there he is again. In this case, he's leaving with the first order. It's going to go to that customer, and then the drone's going to come and fly the order. And so,
Después de un tiempo, la segunda orden está disponible en el depósito. Un empleado cargará el dron con la segunda orden y lo enviará hacia el camión repartidor.
There's two orders there. The pharmacy employee, which is actually one of the graduate students, is going to load up the drone and it will fly off to meet the drone. So this drone has some basic intelligence that is really optimal.
Mientras tanto, el repartidor está entregando el primer paquete.
We were very low budget. I was making the delivery for one, and then the drone's gonna come and give him stuff he needs for customer delivery. I told Daniel he was way too nice for delivery man.
Y aquí llega el dron. El repartidor espera que aterrice, toma el paquete y envía el dron de regreso al depósito.
And you can see with this why you don't really want the customer interacting with the drone.
Yeah.
And this brought some of that realism home. These drones are not cheap and they are a little sensitive, so.
Ahora el repartidor puede ir directamente a realizar la segunda entrega.
case, the pharmacy, and the driver can go on display.
En este video veremos
So, we have a website, it needs to be updated more, it has some information, it has papers and results and some of our other work. I already acknowledged our sponsor on that project, so these are some of our publications. Hopefully, there's gonna be more to come. We did get the best paper of the conference award down here in Chile in 2019. That was one hurdles. And I edited this book, so if you're interested, it's got about 500 pages of women-led research in industrial systems engineering operations research. And it's a very nice, high-quality book, and I recommend it. Chile is represented with 2 chapters, both led by women in 2 different universities. You guys already know about this, but you'll be happy to know more. I'm making all my seminars. I'm adding promos for I4s. So I4s next July. It's in your backyard, and I have the honor and the job of being the program chair. So I appreciate all of you getting the word out, because we need to get really good, high quality papers. They're not papers, they're abstracts and presentations. So look forward to that. And that was me on this trip down. I haven't seen. Vina has some wonderful sunsets, but I haven't seen any that have been really, really good since I've been here. It's the best I can do. So thank you.
Thank you very much, Jackie.
You know, I skipped over a lot of the tech details. If you're interested, I can get you more into the papers. Because as you see, I spent almost an hour. Are there any further questions? I know there were some comments. Yeah.
I don't know if the program that you were talking, did they consider like any synchronization between the tracks and the tones?
Well, so everything we did has a time metric. Okay, so quicker is better. So any waiting time is bad. And the waiting time of the drone is doubly bad because it eats into the drone endurance. So we allow waiting time on either end, but making them come about the same time is really important. So I think it's synchronizing that, but we don't demand that they be at the same place at the same time, like initially. One of them can wait if needed, but it count in practice. We have very little waiting because it's pretty punitive in the objective function. Especially the truck, so the truck costs more than the drone. You know, because think about the time. Other questions or comments?
No, just a quick comment regarding the use of drones. You mentioned that, of course, drone capacity, autonomy are limited here, but technology will evolve, so at the end, those things will be doing much more than they do right now, even in the interaction with the customers and all that. So probably the models are actually more powerful in the perspective of what will happen in the near future.
Well, certainly drone endurance is going to go up, maneuverability, autonomy. I think, you know, having the drone interact with the end customer, I don't know. I think there's some real big issues there.
Interact with the person itself, it needs to interact with the house. So,
Yeah, but you can't control,
space.
but you can't control. I guess, yeah, if you had a landing spot, that's way off in the future. I think I'll be dead by the time that comes. But you want to avoid a drone being able to be manipulated by, because it's not just can the customer do it, what if there's someone else, or so there's issues with that. But yes, and in terms of endurance and load and price, these are things that are going to be cheaper and better. And you know, we're looking again at small parcels. You saw this and fairly light, but you know, if you want to do true kind of last mile delivery, you want to be able to look at bigger things and cell phones and this and stuff like that.
Like the TV set.
Yeah, well, yeah,
That's big.
there, yeah, I mean, there's always going to be limitations.
Hmm.
So, yeah, and that's something that's sponsored Toyota, or equipment company. They're very interested in where that's going, where they need to try to put their development efforts. So this kind of, in a tiny way, helps inform them.
I was thinking also, guys, it came to my mind here, even at the university, there is some potential application of all these at some point. The university has a health network, which is, it has the main hospital and several medical centers. They have a problem with the lab testing. That they take samples from patients and customers everywhere in the city, but the central lab is located here. So they take everything here in tax. From time to time during the day, they have instructors go to the units in the city and they bring the samples here. In my case, I have some of the funny problems in the lab that it coagulates fairly quickly. So more than a couple of times, they have to call me again to take another sample because the transportation of the
It took too long.
it took too long.
I
So,
can see,
so-
yeah, the traffic.
yeah. They could just fly.
They could.
With
So there are some implementations in medical. So with the Terra drones, they're doing some stuff, but there's, in Africa, so Africa, you know, is obviously very challenged with infrastructure. And they're using a fixed wing model, a mini airplane, to go from some central medical depot to a remote clinic. So it's just, it's not, doesn't go to customer, there's no routing issues actually, but it is because of the infrastructure. There is no infrastructure, and so it goes, kind of what you were talking about, it's just it's a fixed route. They're also doing something more like this in North Carolina, but again, it's between two medical things. So it's something again, like you referred to here. Okay. So this is starting a little bit to creep into, again, not in the end customer, but looking at, and then North Carolina, there's plenty of roads, but it's a timing thing, exactly what you talked about, that you don't want these things sitting in a hot truck, in our case, hot, and traffic and so on, that you need to get them as soon as possible. I was at a university in Texas earlier this year, giving a seminar, and one of the professors there told me he was working with a group that is interested in organ transplants, and what they were interested in is flying from Dallas to Houston, which are two of the two major cities in Texas. And if the organs became available, trying to use drones, you know, to go point to point with them. And so they haven't done that yet, but they're in the planning stages of this.
Alice, regarding, because one interesting thing is your beta, how the orders are distributed, because the drone gives you flexibility on the process. Have you looked at what distributions work better with drones, or what are drones maybe not even used?
Well, the results I showed you, that we showed results by beta. I mean, the drones are usable for all betas. But I think as things become more spread out, they become more useful. So what we're starting, after we finish this revision, well, we've already started mentally, is doing the stochastic modeling. So we've got the orders coming with uncertainty according to, you know, some like Poisson distribution or whatever. And then so you kind of decide, do I wait or do I send? It's a much more difficult problem. That's the problem we've always wanted to solve. But when we started this, we're like, can't go there yet. I'm always a believer of crawl, walk, run. And so I'm like, let's do the deterministic, because if we can't do a good job with that, we can be big clouds to pass.
Regarding the same thing that Alejandro was pointing out, I think there are two particular cases where this kind of operational scheme is really interesting. I would think that in an urban context, like you mentioned before, where your trucks essentially are really, really slow and drones are considerably faster than your trucks, not just twice, but maybe even 10 times. In those scenarios, I would think that drones have a huge advantage, and it would make a huge difference maybe in an urban context, even more than the rural context that we are presenting here. And there's another generalization, or not even a generalization, a particular case of the last one that you presented that I think would be interesting, which is when trucks have no capacity, that all the transportation of goods you have to do it by the drones, and basically your trucks are the human resource, that are people that are able to receive the packages on the drones. So you're routing your people, your staff, and drones are taking care of the deliveries. And in another context, the drones are able to move fast around the city, moving the staff as they are being released. Also, you can have these times. And then you have to deal with routing people on the city, which and these people move really slow in a city and congestion and everything. But you need them to receive the packages, the drones. Which is kind of like the same problem, but I feel it would be a realistic instance of how it could be implemented or where it could be useful.
Yeah, we've got some current work. We've got, like I said, several of the students working. And one of the things we're doing with another student is using lockers. So the drone can go to the customer home or can go to a locker, depending if the customer wants to have it home delivery or in a locker. And these lockers are like mini depots, if you could say. And so we're working on something similar to this, but with that idea.
Yeah, those are the stations, the docking stations.
Yeah, base station.
There was a company, Matternet, which was actually.
And they make these things, yeah.
Okay.
Yeah, so, and we were trying, along with what you were saying, we're trying to also, in this one, particularly look at the green aspects of trying to minimize energy costs, which of course the drones, I didn't talk about it, but that's a big advantage of drones, is because they're not giving emissions off, and you know, they're very efficient with their battery fuel and stuff. So I think that's another big motivation that we don't take into account in our objective function, but it easily could be. The other thing is the drones are pretty cheap. I mean, it's not, and they're not fixed infrastructure. So the barrier to entry to capital investment is not so great, which is another big advantage of drones.
Yeah. Another context where they can be particularly interesting is related to health. I imagine a problem where you're routing people that are providing a service. They might be nurses, for instance. But then when they get to a place, they might realize that there's specific supply or materials that they need to perform their service, and drones can get that part, like avoiding additional trips to go get something that you needed that you didn't know that
Or even if you think of maintenance, for example, you have maintenance people that arrive.
Like nurses or technical guys from the
okay, in this part and this other, I don't have it on my truck.
Yeah. Let's do some research together, guys.
There's not a technician like in a couple of blocks away. I can use the drone to pick up whatever. What's it? Materials. We could think of drones taking that part, avoiding the trips for.
Well, good. Yeah, I mean, this whole field is actually pretty fun, and it's been fairly easy to attract students to it because it is, I mean, intuitively you can understand it, but it has some needing kind of modeling optimization problems. And then if you add some physical implementation, so we're actually starting a really exciting project That we bought another drone and to do, actually an indoor application of a drone, which is very rare to do that, so. Because you have positioning issues and safety issues and stuff. But anyway, students really enjoy some of the equipment. Oh, I can go fly drones.
Because on that part you were telling me, you could do a twist on the problem, because generally you're looking at routing problems. But what about inventory problems? If you have maintenance, the guy has to have his van full of equipment just in case he needs it. And have multiple
Right,
vans
right.
going around. Now, if you have drones, you can have everything centralized, reduce the amount of inventory,
Yeah.
use cost just in the inventory.
Yeah. That's-
Instead of routing, it's mostly an inventory problem. What's the optimal inventory in order to provide the same service?
Yeah. Yeah. I like it.
Yeah,
Exactly.
There are, and I encourage, you know, if you guys have a student interested, and we'll do some work together.
And just out of curiosity, do you have access to that phone that you showed us?
Yeah, it's in my office.
So,
It's my personal.
the question here is,
It's
it's something
big.
related to mountain points, but in the near future, we could think of people owning their own drones, who can start wherever and whenever they want to. Like, today, you could use that drone to send stuff to your family in your own city. In
I
theory.
mean, potentially, yeah.
And eventually, people are going to have access to that. It's going to be regulated. There's going to be a moment where you won't be able to just send off your drone because there's going to be lots of drones and they will collide or whatever. But it will be cloudy every day. But at this point, you could do that. You could use that drone to send stuff wherever you want to.
Most of the drones that's being sold, I didn't tell you this, but just to finish things up. Are for sensor imagery, like for taking pictures and sensors. So they're very lightweight, they only carry a camera, and they're small, and they're very, but when you want to do logistics with drones, it's very hard to find drones, because there's no real market for it. I mean, it took us a long time to identify the terror drone and then take delivery of it. So, which I think is important that we have this physical component, because this is a big concern. When we're doing the indoor, with this new project, we're just starting with the indoor drone. You know, we did a lot of investigations, because we're not gonna build a drone, we need to buy it. And then finally found a company that's specialized, they have one model that's designed to work indoors. And so we're gonna have to customize that. But we just took delivery of the base model a few days ago. Okay.
Thank you very much, Alex. Thank you.
Home, thank you.
Thank you, everybody. So this puts ends to our meeting. Thank you for everybody. We'll see you next week. Thanks. See ya.